Hi guys, welcome back to CalcFly videos. In this video, we're going to be talking about how to solve question 5 from 2017 AP Calculus for response portion. Alright, in this problem, we've got two particles moving along the x-axis, and then this is the time interval. So the position of the particle P at time t is given by this function. So this is the position function for particle P. And while the velocity of the particle Q is given by this expression, this function, and particle Q is at position x equals 5 when time t is equal to 0. So basically x q of 0 is equal to 5. So we need to be able to write this down first. This is our condition that is given. So we're going to be trying to solve 4 problems about this situation. In the first problem, it says for this time interval, when is the particle P moving to the left? Okay, if particle P moving to the left, then particle P's velocity has to be less than 0. Okay, so but we don't know the velocity of particle P. We know the position of the particle P, so we can easily figure out the velocity of the particle P by taking the derivative of position of the particle P. So let's figure that out. So the velocity of the particle P is going to be equal to, if I apply the derivative rule for the natural log function, we're going to get 2t minus 2 divided by t squared minus 2t plus 10. Okay. In order to solve this in order to solve this inequality involving this expression, first I need to set this equal to 0. If the entire thing is equal to 0, the top must be 0. So that's why 2t minus 2 has to be equal to 0. So if I solve this equation, we're going to get t is equal to 1. Okay, so now we're going to do a number line, kind of analyze this number this time. So between 0 and 8. So this is 0 until 8, and this is 1 right here. So now between these two time intervals, we need to pick out a time, and we need to analyze that time into the original velocity function. So basically I'm going to select 0.25 right here between 1 and 0 and 1, and I'm going to pick 2 between 1 and 8. So then you need to test these values in the velocity function. So you need to know what is Vp of 0.5. and you need to know what is Vp of 2. Okay. So you can easily calculate that. So I have calculated that when I substitute 0.5 into the velocity function, the result is going to be negative less than 0, so which means velocity between 0 and 1 is always negative, negative, negative. Then when I substitute 2 into the velocity function, the result is positive, which means 1 and 8 velocity is positive. So which means the particle's velocity between 0 and 1 is negative. Right after 1, it becomes positive. So basically, particle P moving to the left on this time interval between 0 and 1. So particle P moves to the left on this time interval between 0 less than t less than 1. Okay. In part B, it says, again, we got the same time interval. Find all times t during which two particles travel in the same direction. Okay. So basically, this problem is like a double number line situation, and we're gonna try to figure out the intersection on those two number lines, and that intersection is going to be our answer. So before that, let me clean up the board really quick. Okay. So part B. Okay, so we know that when I set the velocity of the particle Q, so the Vq of t is equal to 0, which is t squared minus 8t plus 15 is equal to 0. So the results are going to be t equals 5 and t equals 3. So I need to analyze, test these values. So I'm going to do another number line between 0 and 8, and I'm going to put 3 right here, I'm going to put 5 right here, and this is particle Q, so I'm going to put Q right here, and then this is particle P. If you remember that particle P moves to the left between 0 and 1 and moves to the right between 1 and 8. So basically this is going to be negative, 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 positive, 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 positive. Okay, so we're going to do the same thing for particle Q. So for each time interval you need to select values. So for example, let's select 1 from here, let's select 4 from here, let's select 6 from here. So you need to figure out what is VQ of 1, what is VQ of 4, and what is VQ of 6. Okay, so I did those values. Okay, you can also test those values in the original velocity function. So what I came up with is, so VQ of 1 is equal to, actually bigger than 0, VQ of 4 is less than 0, and VQ of 6 is bigger than 0. So which means between 0 and 3 it's positive, and between 3 and 5 it's going to be negative, between 5 and 8 it's going to be positive again. Okay, so as a solution of this problem, you need to find the overlapping region on these two number lines. So if you take closely look at this situation, the solution is going to be equal to between 1 and 3, so between 1 and 3, and 5 and 8. So basically on these two time intervals, these two particles are moving in the same direction. Okay. So if you want to solve this problem, you need to make two number lines and focus on these two number lines and their intersection regions. Okay. Let's move on to part C. In part C, it says find the acceleration of the particle Q. And remember that we know the VQ of t, which is the velocity of the particle Q, which is t squared. Let's remember that t squared minus 8t plus 15. So minus 8t plus 15. So you need to find the acceleration of this, which is going to be equal to 2t minus 8. And evaluate this acceleration when t equals 2. So it's going to be equal to 2 times 2 minus 8, which is negative 4, less than 0. And you need to also evaluate velocity when t equals 2. And that's going to be equal to 2 squared minus 8 times 2 plus 15. And that's going to be equal to 4 minus 16 is negative 12 plus 15. It's going to be equal to 3, which is bigger than 0. So since the signs of the velocity and acceleration came out to be opposite, that means velocity, the particle Q particle Q is slowing down. So slowing down, since the signs of the acceleration of the velocity came out to be opposite. Okay. So let's move on to part D. And part D, it says find the position of the particle Q the first time it changes direction. Okay, so if you go back to the previous slide, so it says first time it changes the direction. So this is the velocity particle Q. So between 0 and until 3 it's positive, but right after t equals 3 it becomes negative, which means this is the first time it changes sign. So basically we need to find the position of particle Q when t equals 3. So x of 3 is going to be equal to, we need to also take into consideration of the initial condition. If you remember, that condition is when time t equals 0, initial position is 5. So we can also take it into consideration. So x of 0 plus from 0 to 3 VQ of t dt. So we know that x of 0 is 5 plus from 0 to 3 velocity of particle Q is t squared minus 8t plus 15 dt. Okay, so now what you gotta do is you need to Find the integral of this expression using the power rule and evaluate it when t equals 3 and when t equals 0 using the first fundamental theorem of calculus. So what I mean is t cubed over 3 minus 4t squared plus 15t from 0 to 3. And this final result is going to be equal to 23. So the position of the particle q when time t equals 3 is going to be equal to 23. Okay, which means the particle is moving to the right. Okay. Alright guys, thanks so much for watching this video. In this video we talked about question 5 from 2017 AP Calculus for response portion. So this problem was mainly about the two particles moving along the x-axis, and we tried to find solutions to the following problems. Alright, if you like this video, don't forget to subscribe, like, share and comment. In the next video we're going to talk about how to solve question 6 from 2017. See you in the next video. Bye bye.